Did you know that when a star dies, its fate depends on its mass? There are three main ways a star can end its life. Low to medium mass stars, including our Sun. When stars like our Sun run out of fuel, hydrogen, in their cores, they enter the final stages of their life. The core contracts, and the outer layers of the star expand, turning the star into a red giant. Eventually, the outer layers are expelled into space, forming a shell of gas known as a planetary nebula. The core that remains contracts further to become a white dwarf, a dense remnant composed mostly of carbon and oxygen. White dwarfs slowly cool over billions of years, fading into black dwarfs, but this process takes much longer than the current age of the universe. High-mass stars. More massive stars go through a more spectacular end. When they run out of fuel, their cores collapse under gravity's immense pressure. This collapse initiates a massive explosion known as a supernova. The supernova can briefly outshine an entire galaxy, releasing an enormous amount of energy and creating heavy elements in the process. The explosion can lead to the formation of neutron stars or black holes, depending on the remnant's mass after the explosion. Supermassive stars. In extremely rare cases, some stars are so massive that even a supernova explosion cannot contain their gravitational collapse. These supermassive stars continue collapsing, leading to the formation of black holes. These black holes can be millions or even billions of times more massive than our Sun and have an incredibly strong gravitational pull. It's important to note that the death of a star is a critical process in the life cycle of the universe, as it releases elements that are essential for the formation of new stars, planets, and even life. Supernova explosions, for example, spread heavy elements and other crucial materials throughout the cosmos, enriching interstellar space and providing the raw materials for future star systems. The study of stellar evolution and the various ways stars die is a fascinating field of astrophysics that helps us understand the processes that shape our universe. Let's delve deeper into the fascinating processes involved in the death of stars and their significance in the universe. Supernovae. Supernovae are some of the most energetic and powerful events in the cosmos. When massive stars, typically more than 8 times the mass of our Sun, exhaust their nuclear fuel, their cores collapse under gravity's overwhelming force. This leads to a cataclysmic explosion, ejecting vast amounts of stellar material into space. During the explosion, the star can briefly outshine an entire galaxy and release an immense amount of energy, including the creation of heavy elements like gold, silver, and uranium. These elements are then dispersed into the interstellar medium, enriching the cosmic material from which future generations of stars and planets will form. Neutron stars. After a supernova explosion, what remains of the core can become a neutron star. Neutron stars are incredibly dense objects, composed almost entirely of neutrons. They are about 1.4 to 3 times the mass of our Sun and have a diameter of only about 10 to 20 kilometers, 6 to 12 miles. Due to their compact size and rapid rotation, neutron stars exhibit fascinating phenomena like intense magnetic fields, emitting beams of radiation that result in pulsar-like effects when observed from Earth. Black holes. In cases where the remnants of a massive star are even more massive, typically more than 3 solar masses, after a supernova, the gravitational collapse continues. This leads to the formation of a black hole, a region of spacetime with such strong gravitational pull that nothing, not even light, can escape its grasp beyond a point called the event horizon. Black holes come in various sizes, from stellar black holes to supermassive black holes found at the centers of galaxies. Stellar recycling. The death of stars is crucial for the recycling of matter in the universe. The elements created during stellar death are released into space, forming part of the interstellar medium. These enriched materials become the building blocks of future generations of stars, planets, and even life. In this way, stars act as cosmic engines, transforming lighter elements into heavier ones through nuclear fusion and then scattering these elements across space upon their demise. White dwarf evolution. As low to medium mass stars, like our Sun, evolve into white dwarfs, they no longer undergo nuclear fusion reactions. Instead, they slowly cool over billions of years. As they cool, they dim and fade into black dwarfs, which are essentially cold, dead remnants of once active stars. However, the universe is currently too young for any black dwarfs to exist because the cooling process takes longer than the current age of the universe. Stellar death is an integral part of the grand cycle of the universe, where matter is continuously transformed and recycled. Understanding the life and death of stars not only provides insight into the fundamental processes of astrophysics but also helps us appreciate our cosmic origins and the interconnectedness of all celestial objects in the vast cosmos. Thanks for watching. We will love for you to subscribe to our channel.